This section is on centre of mass and stability. It's about what centre of mass means. We really need a definition so that we know what we're talking about. If we say where's the centre of mass of an object, we need to know how to find the centre of mass of an object, and then we need to use this to describe whether an object will topple over if it's on a slope or if you tilt it. So first up, centre of mass of an object. This is a definition we need to start from. So it's the point from which all its weight seems to act. Obviously, if you've got an object, it's got lots of little bits to it. Each bit's got its own weight. That would be quite complicated to work out if we were having to do lots of little weights all added together. But we can imagine all the weight seems to act from this one point. That's centre of mass. If you've got a regular object, like a ruler, centre of mass is really simple. It's symmetrical, so it's halfway along. We've got half the mass on this side, half the mass on that side, because it's symmetrical. It's symmetrical that way, so there's a point right in the middle. You can bounce it on your finger like this little girl's doing, but you could just put the point of your finger in the middle and all of the mass would seem to act from that one point. So it's fairly predictable from a regular object. If you get an irregular object like this, much more difficult. It's got a lot of mass over here, less mass in the tail, more mass over here, mass on both sides. Where's its centre of mass going to be? Well, this bird is specially designed so that its centre of mass is on its beak, and that's why you can rest it on this cone here. It might be that this is a bit thicker down here because it looks like more of the bird is behind the cone than in front of it. So perhaps there's a bit of extra density in here to make this bit a bit heavier. Okay, I don't know really from the picture, but I do know its centre of mass must be there because we can support it on that point and it balances. So if we wanted to find the centre of mass in a slightly more systematic way, this little PowerPoint shows us how we do it. So we've got a card which is not symmetrical. You might look at it and judge. If I was putting my finger under that card, where would I put my finger where it would balance? You could do it by trial and error a little bit, or you could use this technique which they sometimes ask you to write about in the exam as an extended answer. So the first thing we do is we make a hole in it, we suspend it from a pin, and then crucially we let it hang freely. And when it hangs freely, what we know is the centre of mass is somewhere vertically below that point. If the centre of mass was over here, it would swing round until it was underneath it. Okay, so we hang a little plumb line on, so there's a weight on here to make sure the string is vertical. We put some lines on there and those lines, and we know the centre of mass is somewhere along that line, but we don't know quite where it is, do we? So what do we do next? Well, all we've got to do is we've got to take a second point, try to make sure these lines aren't too close together, because you'll get a more accurate answer if they're crossing at roughly 90 degrees. Repeat the process, make some more lines. So now we know the centre of mass is on this line and this line. Okay, so there's only one point it can be where those two lines cross. That must be the centre of mass. You can check it by sticking it on a pencil. If you've done a good job, it'll balance on the pencil. So that means we now know what centre of mass means. We know how to find the centre of mass of an irregular object. So probably the most stable thing in a science lab is a Bunsen burner. Here's our Bunsen burner. It's got a lot of mass at the bottom, so its centre of mass is very low. It's also got a very wide base. This means it's almost impossible to knock a Bunsen burner over. If you think about it, if you tilt a Bunsen burner to here, here's its centre of mass, so its weight seems to act all from the centre of mass. What do we notice? Well, this line of action of this force is inside the base. That means that if I let it go, it's going to fall back onto its base. You have to tip a Bunsen burner all the way over to here. Now its centre of mass is just above this point where it's hitting the desk. This one doesn't quite know which way to turn. Theoretically, you might be able to balance it on its edge there. To make it tip over, you've got to tip it even further than that. You've got to tip it all the way over to here, so the line of action of the weight is outside the base. That's when it will topple over. So things with a low centre of mass and a wide base are the most stable kind of object.